moments in history when a single discovery has the power to shake everything we thought we knew. Imagine sitting at your computer, sipping coffee, and reading the headline, "Scientists detect mysterious signal from space." Your heart skips a beat. Is this it, the moment humanity has been waiting for? Or just another false alarm, another trick played by the universe? Stories like this capture us because they touch something primal, the longing to know if we're alone. Since childhood, we've stared at the stars, wondering if someone out there might be staring back. And now, with telescopes sharper than ever and algorithms that can catch the faintest cosmic whispers, the question feels closer than it's ever been. Doesn't that send a shiver down your spine? But with wonder comes doubt. Every strange signal raises hope, yet history is full of false alarms, mysteries that turned out to be nothing more than comets, satellites, or even microwaves here on Earth. Still, the possibility lingers. What if this time it's different? What if this time the cosmos really is speaking? This story isn't just about science, it's about us. How we dream, how we hope, and how we confront the unknown. It's about peeling back the layers of mystery, one signal at a time, until we either find an answer or embrace the silence. So, buckle in, subscribe if you haven't yet, and get ready to journey through the science, the myths, and the tantalizing possibility of first contact. Because the question remains, was it a real message from the stars, or just another echo of our own imagination? Some questions echo across centuries, shaping not just science but the very core of human identity. One of them whispers through the silence of the cosmos, are we alone in the universe? Picture yourself under a clear night sky, surrounded by millions of stars, and suddenly wondering, could someone, or something, be looking back at us? That single thought is like a spark that fuels exploration. And honestly, isn't it thrilling to think our cosmic solitude might only be an illusion? This isn't just a scientific curiosity, it's a deeply personal question. What would it mean for us, as a species, to learn we're not unique? Imagine how it could change the way you see your own life, your place in the grand scheme of things. The search for an answer is both rational and emotional, almost spiritual. It's like trying to find out whether we're a lone candle in an endless night, or part of a vast constellation of lights. Since ancient times, humans have looked to the skies, searching for meaning in the stars. Egyptians, Mayans, Greeks, all built myths and stories about the possibility of life beyond Earth. Today, with powerful telescopes and sophisticated algorithms, we're still on the same quest. The tools have changed, but the essence remains, to know if there's someone else out there. And let's be real, doesn't that make you feel connected to every generation before us? Now, imagine being a scientist dedicating your entire life to this search. It's like casting a net into an infinite ocean, hoping that one day something tugs back. Every attempt is a blend of excitement, frustration, and childlike wonder. And then comes the what if one strange blip of data, one whisper in the noise, was the undeniable proof that we're not alone? Would your heart race with fear, or with joy? This fundamental question is also a mirror, reflecting our own insecurities and desires. Because, at its core, searching for extraterrestrial life is really about trying to understand ourselves. If we're alone, maybe that makes us special. If we're not, maybe it means we're part of something greater than we can imagine. Either way, there's no small answer here, every possibility carries massive weight. But there's another layer, communication. If there is life out there, could we even understand each other? Picture receiving a coded message from light years away, so complex that even the best computers can't crack it at first. That thought alone is enough to give anyone goosebumps. How would you react if the universe finally spoke back? And here's the kicker, this question, are we alone, has the power to unite humanity. For a moment, our differences, political, cultural, religious, seem tiny compared to the bigger mystery. Because when you're standing beneath the vastness of the night sky, arguing over borders feels like fighting over who gets the bigger slice of sand on a deserted island. But what if a real signal, or real clue, was already found? That's where the story takes its next step. Have you ever wondered what it would feel like to spend your whole life just listening to the silence of space? That's exactly what a group of scientists set out to do in the 1960s when the SETI project, Search for Extraterrestrial Intelligence, was born. Back then, the world was caught up in the Cold War, but these researchers dared to look beyond earthly rivalries. They turned their gaze to the stars, hoping to catch a whisper from another civilization. Bold? Absolutely. But isn't boldness the engine of discovery? SETI wasn't just a scientific program, it was a declaration of hope. Instead of waiting for flying saucers to land on Earth, they decided to go hunting for signals. Imagine twisting the dial on an old radio, but instead of tuning into your local station, you're searching for a broadcast from across the galaxy. That was the vision. And the odds? Astronomical. But still, they believed. Because, let's be honest, if the universe is so vast, how strange would it be if we were the only ones? At first, the project was small and experimental. Computers were primitive compared to today, algorithms were limited, and patience was the main tool. Yet, the drive behind it was stronger than technology, it was fueled by human curiosity. Think about it, would you commit years of your life to something that might never yield an answer? Many of them did. And they did it with the conviction that maybe, just maybe, one day the cosmos would speak. One of the most remarkable aspects of SETI is the willingness to invest in something with no guaranteed outcome. It's like planting a tree knowing you might never live to see it grow tall. Critics often asked, why pour resources into this? But the scientists countered with a simple idea: the chance of hearing another intelligence, however small, was worth every effort. If you were in their shoes, would you take that gamble? Over time, SETI grew, not just in scope but in collaboration. More telescopes, more data, more countries joining the mission. Ordinary citizens even joined in through SETI at home, turning their home computers into mini research stations. Suddenly, millions of people worldwide were part of this cosmic search. Isn't it amazing how a dream so vast could make strangers across the globe feel connected? What's fascinating is how SETI influenced culture. It fueled science fiction, inspired movies, books, and even philosophical debates. It made people imagine not only what aliens might look like, but how we should respond if they said hello. Science and imagination danced together, shaping both technology and storytelling. It's proof that when humans dream, they don't just build machines, they build meaning. But the story doesn't end there. The decades rolled on, the technology advanced, and then, suddenly, an intriguing signal emerged. Not from some far-off galaxy, but from our closest stellar neighbor, Proxima Centauri. Imagine the shock of scanning the cosmos for decades, often finding nothing but static, and then suddenly, there it is. A signal. Not just from anywhere, but from Proxima Centauri, our closest stellar neighbor, only 4.2 light-years away. Think about that for a moment. In the endless expanse of the universe, the potential whisper of intelligence seemed to come from just next door. Doesn't that make your imagination race? The detection was subtle, buried in a sea of radio noise. At first glance, it looked like countless other signals scientists had dismissed before. But this one had a peculiarity: it carried a frequency that didn't match natural cosmic sources. It was steady, consistent, almost deliberate. Like the faint hum of a machine left running in the distance. And it raised the irresistible question: could this be a deliberate transmission? Proxima Centauri is already famous for hosting exoplanets, one of them sitting in the so-called habitable zone. That alone had scientists dreaming of oceans, atmospheres, maybe even primitive life. So when this mysterious radio signal was traced back to its vicinity, the speculation went wild. What are the odds that the star closest to us also hides an intelligent neighbor? Too good to ignore, right? Of course, excitement had to be tempered with caution. Astronomers know all too well that signals can mislead. Satellites, Earth-based interference, even glitches in equipment have sparked false alarms before. But the Proxima signal felt different. It was sharp, it was narrowband, exactly the kind of signature you'd expect if someone were trying to be noticed. Imagine the hairs standing on your neck if you were the one analyzing that data. News of the detection spread quickly through the scientific community and, inevitably, the media. Headlines spoke of possible alien contact, and the public was captivated. For a brief moment, humanity leaned closer to its screens, united in curiosity. Could this finally be it? The moment we've been waiting for? You can almost feel the tension building, like a drumbeat in the background. Scientists, though, remained cautious. They insisted on more tests, more analysis, more peer review. It's one thing to hear a strange noise, it's another to prove it didn't come from us. After all, claiming alien contact is the boldest statement science could ever make. And as history shows, every whisper from the stars deserves skepticism. But still, the possibility lingered. Isn't it human nature to hope, even when reason tells us to wait? And just as excitement reached its peak, another story unfolded. This time, it wasn't about a star, but about Mars, a place we've been exploring with robots for decades. And in one bold experiment, a spacecraft simulated what the very first contact with extraterrestrials might feel like. Picture this, humanity staging a dress rehearsal for the most extraordinary moment in history, first contact with extraterrestrial intelligence. That's exactly what the European Space Agency attempted with its Trace gas orbiter around Mars. Instead of waiting passively for the universe to speak, they decided to simulate the experience. They sent out a carefully crafted signal, one that mimicked what an alien transmission might look like, and then challenged scientists and ordinary people alike to decode it. Doesn't that sound like the ultimate cosmic puzzle? The experiment wasn't just about fun, it was serious science. By sending an encrypted message from the orbiter back to Earth, ESA wanted to test how quickly and effectively humanity could respond to a real alien signal. Would we have the tools, the algorithms, the teamwork to crack the code? Or would confusion and chaos slow us down? Think of it as a fire drill for the entire planet, except instead of testing alarms and exits, we were testing curiosity and collaboration. What made this simulation so fascinating was its openness. Instead of limiting the challenge to a small group of experts, ESA threw the doors wide open. Universities, hobbyists, and even school groups could try their hand at decoding the transmission. Imagine being a teenager, sitting at your laptop, and suddenly realizing you're part of an experiment that mirrors the moment humanity might first hear from another world. Isn't that the kind of experience that stays with you forever? The signal itself wasn't random, it was complex, structured, designed to carry meaning. Participants had to analyze it, search for patterns, and test different approaches. For some, it was a thrilling dive into cryptography, for others, a window into the challenge of interstellar communication. And in that process, something remarkable happened. People across the globe, from different backgrounds and languages, united around the same mission. Doesn't that sound like a glimpse of how first contact could actually bring us together? Of course, the exercise also revealed how difficult such a task would be in real life. Even with a man-made signal, decoding took time, effort, and collaboration. Now imagine if the message were truly alien, carrying concepts, symbols, or logic completely foreign to us. Would we even recognize it as a message? Or might we stare at it for years, missing the meaning entirely? That's the kind of humbling thought experiments like this are meant to provoke. Beyond the technical challenge, there was also a psychological one. People began asking themselves, if this were real, how would I feel? Excited? Afraid? Overwhelmed? The simulation reminded us that first contact isn't just a scientific event, it's an emotional and cultural earthquake. It forces us to confront not just how we would respond, but also who we are as a species. Would we rise to the occasion, or stumble under the weight of our own differences? And as the decoding process wrapped up, one truth became clearer than ever: the tools we use to detect and analyze signals, our radio telescopes, our algorithms, our artificial intelligence, will define how ready we are when the universe finally sends a real hello. Which leads us straight into the heart of the next question: how exactly do we detect these signals in the first place? Imagine standing in a crowded room filled with thousands of conversations, laughter, footsteps, and music. Now picture trying to hear a single whisper across that chaos. That's essentially what astronomers face when searching for alien signals in the vast cosmic noise. The universe is buzzing with natural radio emissions, pulsars, quasars, even the crackle of our own atmosphere. To find a potential transmission in that sea of sound, scientists turn to their most powerful ears, radio telescopes. Doesn't it feel almost poetic that we're listening to the sky itself? Radio telescopes act like gigantic satellite dishes, some spanning hundreds of meters across. They scan the heavens, collecting waves invisible to our eyes, waves that might carry the faint signature of technology. Each observation generates enormous amounts of data, far too much for humans to analyze manually. That's where algorithms come into play, sifting through the noise in search of patterns, structured, repeating signals that nature doesn't usually produce. Ever tried spotting a single melody in static? That's the challenge they face. But here's where things get even more exciting: artificial intelligence has entered the stage. Modern AI doesn't just look for obvious repetitions, it learns, adapts, and recognizes subtle anomalies that older methods might overlook. Think of it as training a digital detective to distinguish between the chatter of stars and the deliberate call of intelligence. Isn't it incredible how the same technology that powers your smartphone assistant could one day help us spot alien life? Of course, detection isn't only about recognizing patterns, it's also about ruling out fakes. Earth is full of interference. Satellites, cell towers, radar, even microwaves can mimic extraterrestrial signals. That means every hit must be carefully double-checked. Scientists often compare signals captured by multiple telescopes spread across the world. If it's real, it should appear consistently from space, not just from a single location. Can you imagine the tension in those moments, waiting to see if the signal survives scrutiny? What's fascinating is how detection methods have evolved. In the early days, it was like fishing with a single line, slow, limited, and uncertain. Today, with massive telescope arrays and machine learning, it's more like casting a giant net, capable of catching whispers from across light years. Yet, despite these advances, the process is still painstaking. A single candidate signal might take months to analyze, cross-check, and validate. Patience, as always, is the scientist's best friend. And while the methods are high-tech, the spirit behind them remains deeply human. It's about curiosity, about refusing to accept silence without asking what lies behind it. Every new algorithm, every AI upgrade, is like sharpening our senses for that one moment when the universe might finally reveal its voice. Don't you wonder what it will feel like the day we actually hear something unmistakable? But even if we do detect a promising signal, the work doesn't stop there. Scientists need to decide, is it truly authentic? Does it meet the strict criteria to be considered alien in origin? And that leads us directly into the next big question: what does it take for a signal to be deemed genuine? Think of it like this: detecting a strange signal in space is a lot like finding a mysterious footprint in the forest. At first glance, it might look unusual, maybe even human, but before declaring you've discovered someone new, you've got to prove it's not just an animal track or a trick of the wind. That's exactly how scientists approach authenticity. The first rule? Persistence. A genuine extraterrestrial signal can't be a fleeting blip. It needs to repeat, to hold steady over time, showing consistency that natural noise or equipment glitches simply don't have. Wouldn't you expect a real hello to last long enough to notice? Then comes the question of origin. For a signal to be considered authentic, it has to come from a defined place in the sky. Scientists carefully track its coordinates, making sure it's not bouncing around or shifting like man-made interference often does. Imagine aiming a telescope at the same star night after night, and each time, the signal is still there, unwavering. Doesn't that sound a lot more convincing than static that pops up and disappears randomly? Artificiality is another crucial factor. Natural phenomena produce broad, messy radio emissions. But intelligent technology, whether ours or someone else's, tends to generate narrowband, structured signals, sharp, clean, and precise. It's like comparing the chaotic splash of raindrops to the rhythmic beat of a drum. When astronomers stumble on something that feels too organized to be nature's doing, their hearts skip a beat. Could this be the sign of an engineered message? Of course, perhaps the hardest step of all is ruling out interference. Earth is noisy, Our satellites, cell phones, and even kitchen microwaves can mimic cosmic whispers. That's why scientists cross-check detections using multiple observatories. If one telescope hears it, but another doesn't, odds are it's a false alarm. But if 2 or 3 distant observatories pick up the same pattern, pointing to the same patch of sky, suddenly the stakes rise. Isn't it thrilling to think about how fragile yet powerful that confirmation can be? These criteria form a kind of checklist, a safeguard against jumping to conclusions. Because the last thing the scientific community wants is to announce alien contact, only to find out later it was a wayward satellite or a glitchy instrument. That would be like shouting you found buried treasure, only to dig up a soda can. The credibility of science depends on careful, cautious validation. Wouldn't you want certainty before making history? And beyond the science, there's also the weight of responsibility. A false claim doesn't just damage reputations, it shakes public trust. That's why every potential candidate is examined with almost obsessive rigor. If a signal passes every test, persistence, location, artificiality, elimination of interference, then, and only then, does it move closer to being considered genuine. And yet, history shows us that even the most promising detections can crumble under scrutiny. Which brings us to one of the most famous stories in the search for extraterrestrial intelligence, a signal so mysterious it sparked decades of debate, excitement, and ultimately disappointment, the legendary WOW signal. It was the summer of 1977, and an astronomer named Jerry Ehman was scanning data from the Big Ear radio telescope in Ohio when something extraordinary caught his eye. A sharp, narrow-band signal, unlike anything seen before, appeared on the printout. In a moment of disbelief, Ehman circled the reading and scribbled one simple word in the margin: "Wow." That single exclamation would go on to become one of the most famous mysteries in the search for extraterrestrial life. Can you imagine the rush of adrenaline he must have felt staring at those numbers? The WOW signal lasted for just 72 seconds, the exact time it took the telescope to sweep past its source. It was never heard again. Its frequency was suspiciously specific, right around the hydrogen line, a cosmic channel many scientists believe an intelligent species might use to communicate. The sheer strangeness of it set imaginations on fire. Could it really have been a message, a deliberate beacon sent to us across the stars? Or was it nature playing tricks on our instruments? Decades later, researchers have proposed all kinds of explanations. Some argue it might have been caused by comets passing through the region, their hydrogen clouds mimicking a deliberate signal. Others suggest it could have been an overlooked satellite, or simply an unknown natural phenomenon. Yet, despite years of investigation, no definitive answer has ever been found. Doesn't that lingering uncertainty feel both frustrating and exciting at the same time? And the WOW signal isn't alone. Over the years, astronomers have detected dozens of strange blips, unusual bursts, repeating fast radio signals, unexpected spikes in data that at first glance looked promising. Each time, the initial thrill filled the headlines, sparking talk of first contact. But time and careful analysis often revealed the truth: interference, natural cosmic events, or technical glitches. Isn't it fascinating how quickly hope can turn into disappointment? But here's the thing, these false alarms are far from failures. Every single one teaches scientists how to refine their methods, how to separate the ordinary from the extraordinary. They sharpen the tools, the algorithms, and the discipline needed to face the next mysterious signal. It's like learning from every false note in a symphony so you'll recognize the true melody when it finally plays. Don't you think those mistakes are actually vital steps forward? The WOW signal, in particular, continues to haunt the imagination. It's become a kind of legend, a story told in both scientific papers and pop culture. For some, it remains a tantalizing hint that we really did catch a fleeting hello, only to lose it in the noise. For others, it's a sobering reminder that the universe is complex, and not every mystery means contact. But either way, it leaves us with the sense that the cosmos still has secrets waiting to be uncovered. And that leads to a deeper question: why do false alarms happen so often in the first place? What is it about the universe, or even about ourselves, that makes us so vulnerable to being fooled by the signals we find? Why do false alarms happen so often in the hunt for alien signals? The truth is, the universe is a noisy place. Stars flare, pulsars beam like cosmic lighthouses, and galaxies hum with energy across the spectrum. Some of these natural events can produce signals that look oddly artificial at first glance. Imagine mistaking the rhythmic beat of a distant drum for a human heartbeat. Our telescopes often face the same challenge. Doesn't it make sense that, in such a crowded orchestra, we might confuse a natural instrument for a deliberate voice? Then there are the limitations of our own technology. Even with powerful telescopes, we're still bound by the imperfections of our machines. Sensitive equipment can glitch, generate static, or misinterpret random bursts of energy. And because data sets are so massive, a single anomaly can look convincing until it's examined under a microscope. Think of it like seeing a face in the clouds. Our minds fill in the gaps, but the shape isn't really there. How many times, do you think, has hope blinded us to technical flaws? And we can't ignore the elephant in the room: human bias. Scientists are human, after all, and the dream of finding proof of extraterrestrial life is powerful. Sometimes, that longing shapes the way we interpret data. Psychologists call it confirmation bias, our tendency to see what we want to see. It's like hearing your name in a crowded room. Your brain tunes in, even if no one was calling you. Could it be that our eagerness sometimes tricks us into hearing voices in the static? False alarms also happen because of Earth itself. Our planet is surrounded by a growing cloud of human-made radio interference, satellites, radar, Wi-Fi, even microwave ovens. These signals bounce, scatter, and sometimes mimic the very patterns astronomers are searching for. In fact, one infamous mystery signal turned out to be a microwave in the observatory's break room. Can you imagine the mix of laughter and embarrassment when they figured that out? But here's the catch: every false alarm sharpens our skills. Each disappointment pushes scientists to develop better filters, stronger algorithms, and smarter ways of cross-checking data. It's a bit like learning to distinguish counterfeit money. The more fakes you study, the better you get at spotting the real thing. Isn't it ironic that failure might be the very thing preparing us for success? What's truly fascinating is that these false alarms don't dampen curiosity, they amplify it. Every anomaly, even when explained, is proof that the universe is alive with activity, full of mysteries waiting to be solved. The chase itself becomes part of the reward. Because deep down, humans thrive on wonder, on the edge of discovery. Don't you think it's that restless spirit that keeps us listening, even after disappointment? And now, with new generations of technology coming online, scientists believe we're better equipped than ever to separate false alarms from genuine signals. Tools with unprecedented sensitivity are about to transform the way we search the skies. Which brings us to the breakthroughs of today, the cutting-edge instruments being built in 2024 and 2025. Imagine trying to catch the faintest whisper in a stadium filled with roaring fans. That's what astronomers face when listening to the universe. But now, with the Square Kilometre Array, better known as SKA, they finally have a megaphone for the cosmos. This massive project, stretching across South Africa and Australia, is designed to be the most sensitive radio telescope ever built. With an effective collecting area of 1 square kilometer, it's like giving humanity a new pair of ears, capable of picking up signals a billion times fainter than anything we've heard before. Doesn't that sound like science fiction turned real? The SKA isn't just about size, it's about precision. By linking thousands of antennas across continents, scientists create a telescope that acts as if it were one giant dish. The result? Unparalleled resolution and clarity. It's as if we've gone from fuzzy black and white TV to Ultra HD cosmic streaming. Suddenly, signals that once drowned in static might stand out like shining beacons. Could this be the tool that finally tips the scales in our favor? And it's not only SKA. Other cutting-edge projects are joining the hunt. Upgraded instruments like China's FAST telescope, nicknamed the Eye of Heaven, are already scanning the skies with unmatched sensitivity. Add to that the power of machine learning, where artificial intelligence sifts through oceans of data, spotting anomalies faster than any human could. Together, these tools form a kind of global listening network, an orchestra of machines tuned to the music of the stars. Doesn't that give you chills thinking about what they might find? These technologies aren't just about hearing faint signals, they're about ruling out false ones. With better sensitivity comes better filtering. The more data you collect, the better your chances of separating earthly noise from cosmic whispers. Imagine how powerful it is to detect a signal, cross-check it instantly across multiple observatories, and know with confidence whether it's real. It's like giving science a lie detector for the universe. But perhaps the most exciting aspect is the timeline. These aren't far-off dreams. SKA is under construction right now, with phases coming online throughout the 2020s. Within just a few years, the data will start pouring in, more than any human could analyze alone. That's why AI isn't just useful, it's essential. Without it, we'd drown in the flood of cosmic information. Do you see how the future of discovery is tied not only to bigger machines, but smarter minds working alongside them? What makes this even more fascinating is the possibility of catching not just loud, obvious transmissions, but faint, accidental ones, like overhearing a neighbor's radio through the walls. Civilization elsewhere might not even mean to broadcast, yet their technology could leave traces detectable across light years. Isn't it wild to think we might discover them not because they said hello, but because they simply left their lights on? With tools this powerful, scientists are preparing for a new era in the search for life. But there's an important distinction to make. Not all discoveries will point to intelligent beings, some will reveal life in simpler, biological forms. Which raises the next big question: how do we separate signs of life from signs of intelligence? When scientists talk about finding life in the universe, they don't always mean little green beings waving back at us. More often, they're hunting for biosignatures, the chemical fingerprints that suggest biology is at work. Picture looking at a planet's atmosphere and spotting oxygen, methane, or water vapor in unusual balance. That imbalance could mean something is breathing, growing, or thriving there. It's like walking into a room and smelling fresh coffee. You didn't see anyone make it, but the evidence is hanging in the air. Doesn't that make you wonder what invisible stories the cosmos might be telling? But here's the twist: biosignatures alone don't equal intelligence. They tell us life might exist, but not whether that life is thinking, building, or communicating. Take Earth as an example. Our planet was teeming with microbes for billions of years before humans ever evolved. If an alien telescope had looked our way back then, they might have spotted oxygen but never suspected skyscrapers, satellites, or smartphones. Isn't it humbling to realize that life is common, but intelligence might be rare? Technosignatures, on the other hand, are different. They're the fingerprints of technology, narrowband radio signals, laser pulses, or even the telltale glow of artificial lights on a planet's surface. In short, they're evidence not just of life, but of minds trying to shape their environment. Imagine looking through a telescope and noticing a strange, uniform pattern of light on a distant world. That would be like seeing city lights from orbit, the kind of clue that screams intelligence. Wouldn't that change everything we thought we knew? The challenge, of course, is telling one from the other. Biosignatures can be mimicked by natural processes. Methane, for example, can come from volcanoes as easily as from microbes. Meanwhile, technosignatures might be faint, fleeting, or buried under noise. So scientists must tread carefully, checking and double-checking before declaring a discovery. It's the ultimate cosmic detective story. Was that strange signal just a trick of physics, or was it the deliberate call of another civilization? Another fascinating thought: what if alien life is intelligent, but not technological? Dolphins, elephants, and octopuses on Earth are highly intelligent, yet they don't build radios or spaceships. Somewhere out there, could there be a species just as smart, but uninterested, or incapable of communicating across the stars? How would we even recognize them? Doesn't that challenge our assumptions about what intelligence really means? This distinction also sparks a deeper reflection on ourselves. What will our legacy be in the cosmos, a planet glowing with biological signs, or one that broadcasts its technology into the void? Are we destined to be noticed because of our biology, or because of our machines? Either way, our footprint is already out there, carried by radio waves that left Earth decades ago. Could someone be listening to us right now? And if life can exist without technology, and technology can exist without communication, then what else might be hiding out there? Sometimes the best clues don't come from signals at all, but from strange objects drifting into our solar system, visitors that raise questions we never expected to ask. In 2017, the world of astronomy was shaken by the arrival of something truly unexpected, an object from beyond our solar system. It was given the name Oumuamua, a Hawaiian word meaning scout or messenger. Unlike comets or asteroids we had seen before, this one was different. Its path revealed it wasn't bound to the sun, it came from the stars and was simply passing through. Imagine standing on the shore and spotting a bottle drifting in from a distant ocean. Wouldn't you wonder where it came from, and who might have sent it? Oumuamua was strange in more ways than one. It had an unusual shape, long and thin, almost like a cigar, something no natural asteroid we'd seen before resembled. It also lacked the typical dust tail of a comet, yet accelerated slightly as if being pushed by something invisible. These oddities led some scientists to speculate wildly. Could it be an artificial probe, a piece of alien technology drifting silently across the cosmos? The idea lit up headlines worldwide. Doesn't your mind race at the thought of a possible alien artifact just flying past us unnoticed? Skeptics, of course, pointed to natural explanations. Maybe it was a fragment of a shattered planet, or a chunk of exotic ice releasing gas too faint for us to see. But the truth is, no single theory fully explains all of Oumuamua's quirks. And perhaps that's what makes it so compelling, it sits in that gray area where science and imagination collide. Wouldn't you agree that sometimes the greatest mysteries are the ones science can't pin down right away? Then came another visitor, 2I/Borisov in 2019, followed by 3I/Atlas. Unlike Oumuamua, Borisov behaved more like a classic comet, complete with a tail of gas and dust. But its interstellar origin confirms something profound: our solar system isn't isolated. Objects from other stars wander in, leaving faint traces of other worlds. It's like finding seashells washed up on your doorstep, proof that there's a vast ocean beyond the horizon. Don't you think that makes the universe feel a little more connected? The arrival of these interstellar objects forces us to think differently. If natural visitors can drift here, then why not artificial ones? What if civilizations elsewhere launch probes that, by accident or design, travel between stars? Could Oumuamua have been one of them, slipping past without stopping? The idea sounds like science fiction, but then again, so did the idea of interstellar travel, until we actually saw something cross into our backyard. Even if these objects are purely natural, they're still priceless. They carry chemical fingerprints from other star systems, clues about how planets form elsewhere. Studying them is like receiving a postcard from another neighborhood in the galaxy. And who wouldn't be curious to read a message carried across such distance? And here's the thrilling part: we're just at the beginning. As telescopes get better, we're bound to spot more of these wanderers. Some may look ordinary, some may look strange, and maybe one will force us to confront questions we're not ready to answer. But when that day comes, we'll need a clear plan, a protocol, for what to do if we ever confirm first contact. Imagine the moment: a signal is detected, verified, and every test says it's not from Earth. Humanity is standing on the edge of history. What happens next? Contrary to Hollywood movies, there's no red phone in a secret bunker. Instead, science has a playbook, the First Contact Protocol. Its first step is simple but crucial: confirmation. The signal must be independently verified by other observatories around the world. Without that, there's no moving forward. Doesn't that make sense, given how high the stakes are? Once verification is underway, the process shifts to transparency. The data is shared, not hidden. Other scientists, across different institutions and countries, are invited to examine it. Peer review becomes the backbone of credibility. Just like no single witness can convict in a courtroom, no single observatory can declare alien contact. It has to be tested, challenged, and confirmed by many eyes and minds. Wouldn't you want certainty before rewriting humanity's place in the cosmos? The next stage is communication, but not to the public just yet. First, international bodies like the United Nations get involved. After all, a discovery of this magnitude isn't owned by one country or one lab, it belongs to all of humanity. The International Academy of Astronautics has drafted guidelines suggesting how scientists should handle such a discovery, emphasizing cooperation, caution, and responsibility. Doesn't it feel comforting to know that some thought has already gone into preparing for the unimaginable? Eventually, though, the world must be told. The public announcement would be carefully worded, avoiding sensationalism but conveying the truth. Imagine the press conferences, the headlines, the wave of emotions sweeping across the globe. The message would likely stress uncertainty first, that a signal has been detected and is being studied. Only when the evidence becomes ironclad would anyone dare to say the words, "We are not alone." Can you picture the electricity in the air at that moment? Another part of the protocol addresses something equally important: response. If a signal is indeed from an intelligent civilization, should we reply? And if so, who speaks for Earth? There's no universal agreement. Some argue we should listen quietly, like cautious explorers entering a dark cave. Others believe we should introduce ourselves proudly, declaring our existence. What would you vote for, silence or a hello? The ethical questions run deep. What if responding puts us at risk? What if silence wastes a once-in-a-lifetime chance at dialogue? Scientists, philosophers, and policymakers debate endlessly, knowing that the decision could shape humanity's future. It's a responsibility no generation before us has faced, and one we may soon encounter. Isn't that both thrilling and terrifying at the same time? And while protocols guide the science, they can't control human emotions. The news of first contact would ripple across cultures, faiths, and societies in unpredictable ways. Some would rejoice, others might panic. Which brings us to the next chapter of this story. How would humanity, culturally, psychologically, and politically, react to such a discovery? Picture the moment when the news breaks: humanity is not alone. Some people would cheer, rushing into the streets as if celebrating a new era. Others might fall silent, overwhelmed by the sheer scale of the revelation. For many, it would feel like standing at the edge of an ocean, realizing the horizon extends farther than they ever dreamed. Would your first reaction be joy, fear, or disbelief? Religions across the globe would face profound questions. How would centuries-old doctrines adapt to the reality of life beyond Earth? Some might see it as confirmation of divine creation's vastness, proof that God's work spans galaxies. Others might wrestle with contradictions, fearing a challenge to traditional beliefs. Yet history shows that faith often evolves when faced with new truths. Could this discovery spark a spiritual renaissance, one that unites rather than divides? Psychologically, the impact would be just as deep. For generations, humans have placed themselves at the center of the story. Finding intelligence elsewhere would shatter that illusion. Some might feel insignificant, like ants in a sprawling forest. But others could feel liberated, inspired by the idea that we're part of a cosmic community. Which would you choose, shrinking under the vastness or standing taller because of it? Politically, the news would send shockwaves. Governments would scramble to form policies, wondering whether to treat aliens as potential allies, rivals, or threats. National rivalries could intensify as countries compete to control information or claim leadership in first contact. Or perhaps, for the first time, nations would set aside their disputes, realizing humanity's survival and future transcend borders. Do you think we'd unite, or fight harder over who speaks for Earth? Economically, the effects could ripple through every industry. Imagine how science, technology, and exploration would surge, fueled by the hope of understanding alien knowledge. But at the same time, markets could wobble under the weight of uncertainty. Would people cling to the familiar, or race headlong into the new frontier? And how would that shape your own choices in life? Culturally, art, music, and storytelling would explode with inspiration. New myths would be born, fresh perspectives would enter literature and cinema, and humanity's creative spirit would be electrified by the confirmation of the other. In a sense, aliens would not only change our science, they'd change the way we imagine ourselves. Isn't that the most human response of all? But with all the wonder comes challenge. How do we manage fear, misinformation, and the potential for chaos? How do we prepare for the unknown without losing ourselves in it? And while society wrestles with these questions, scientists still face their own obstacles, because making sense of the universe comes with staggering technical challenges. Listening to the universe isn't as simple as pointing a giant dish at the sky. Earth itself is buzzing with noise. Cell phones, satellites, radar, and even microwaves in break rooms can mimic signals from the stars. Astronomers often spend weeks chasing what looks like a potential alien message, only to discover it came from a passing aircraft or a local device. Imagine the frustration of thinking you've heard a cosmic whisper, only to find out it was your neighbor's Wi-Fi. Doesn't that show just how fragile the search really is? Then there's the matter of distance. The universe is unimaginably vast. Even the closest star system, Proxima Centauri, is over 4 years away at the speed of light. That means if aliens there sent us a message today, we wouldn't hear it until 4 years later, and our reply would take another 4 years to reach them. It's like trying to have a conversation through postcards mailed across oceans. Can you imagine how slow and difficult that dialogue would be? Our technology, as advanced as it feels, is still limited. Radio telescopes can only scan portions of the sky at a time, and there are billions of stars to examine. Add to that the challenge of processing mountains of data, petabytes upon petabytes, and you begin to see the scale of the problem. Even with AI, sorting through the cosmic static is like looking for a single grain of sand in a desert. Doesn't that make the search both daunting and awe-inspiring? And let's not forget about resources. Building and maintaining massive telescopes costs billions, and not every country is eager to fund such long-term projects. Some see the search for extraterrestrial intelligence as a gamble, investing in something that may never pay off. But others argue that even if we never find aliens, the technology and knowledge gained along the way are priceless. Would you take the risk of funding the unknown? Another challenge is timing. What if alien civilizations are broadcasting, but only for a brief moment in their history? Radio waves might spill into space for a century or two before they move on to new technologies. If our listening doesn't overlap with their speaking, we could miss them entirely. It's like tuning into a radio station that played your favorite song, only decades before you were born. Isn't that a chilling thought, that we might just be too early or too late? Even the signals we do detect may not be clear. They could be weak, distorted, or completely alien in form. Decoding them would be like trying to understand a language with no alphabet, no grammar, and no Rosetta Stone. Could we even recognize intelligence if it didn't resemble our own? What if the universe has been speaking all along, and we've simply failed to notice? These challenges remind us that the search isn't easy, and maybe that's why it's so compelling. Each obstacle forces us to innovate, to stretch our imagination, to push technology further. And as we wrestle with the difficulties of today, we also look ahead to the possibilities of tomorrow, where artificial intelligence, new telescopes, and philosophical questions like the Fermi paradox might redefine the future of the search. Looking ahead, the search for extraterrestrial intelligence is about to enter a new era, one driven by technology more powerful than anything we've had before. Artificial intelligence is becoming the beating heart of the hunt, scanning unimaginable amounts of data, spotting subtle patterns that human eyes would miss. It's like giving the universe its own translator, one that grows smarter with every signal it hears. Could it be that the first true alien message won't be recognized by us, but by a machine trained to hear the extraordinary hidden in the ordinary? New telescopes, like the James Webb Space Telescope and the upcoming Square Kilometre Array, are sharpening our vision and our hearing. They allow us not just to scan the skies for radio signals, but to analyze atmospheres, detect biosignatures, and maybe even spot artificial lights on distant planets. We're building tools that make the invisible visible. Isn't it remarkable to think that somewhere, right now, the first faint hint of another world's breath or heartbeat might already be recorded in the data, waiting to be noticed? Yet even with all these advances, we collide with one of science's most unsettling puzzles, the Fermi paradox. If the universe is so vast, with billions of stars and planets, where is everyone? Why haven't we heard from anyone yet? Some say civilizations rise and fall too quickly, others believe we're simply not listening the right way. Maybe the universe is brimming with voices, but we're deaf to their language. Doesn't that question keep you awake at night? Philosophically, the future of the search is also about us. If we never find anyone else, does that make humanity the universe's only storyteller? Or does it mean we're searching with the wrong assumptions, blinded by our Earth-based perspective? The paradox forces us to look inward as much as outward, to question what it means to be intelligent, to communicate, to exist. Could it be that the real discovery waiting for us is not them, but a deeper understanding of us? At the same time, there's a growing belief that the breakthrough could come not with a bang, but a whisper. Instead of a clear message, maybe we'll notice something small, an odd flicker of light, an unexplained anomaly in data, a signal so subtle it takes decades to confirm. When it comes, it might not feel like science fiction, it might feel quiet, slow, almost ordinary. But isn't that often how history changes, not in explosions, but in subtle shifts that ripple outward? And let's not forget the role of philosophy and imagination. Each new discovery, even if it isn't proof of aliens, reshapes our understanding of the cosmos. It challenges our sense of scale, our place in the story, our dreams of the future. Whether or not we ever confirm another civilization, the act of searching keeps us connected to the universe, restless, curious, and alive. Isn't the journey itself part of the reward? The future of the search is uncertain, but one thing is undeniable: humanity won't stop listening. With every new tool, every algorithm, every philosophical debate, we inch closer to an answer, whether it's a resounding yes or a haunting silence. And as the quest continues, we're left with the most thrilling possibility of all, that tomorrow might be the day we finally hear the universe say hello. So here we are, after traveling through decades of science, stories, and signals, left with one burning truth: the universe is still keeping its secrets. Maybe we'll confirm a real message tomorrow, or maybe silence will stretch on for centuries. But ask yourself, would you rather live in a world where we stop searching, or one where curiosity keeps pushing us forward? Think about it: if we're truly alone, doesn't that make our existence even more precious? And if we're not, if there's someone out there, it means we're part of a greater story, one written across galaxies. Either way, the search teaches us something deeper about ourselves. Isn't that reason enough to keep listening? What would it mean for your life if proof of extraterrestrial intelligence arrived? Would it change your faith, your fears, your ambitions? Or would it remind you that life, fragile and fleeting as it is, deserves to be lived with more meaning? Sometimes the most important questions aren't about them, they're about us. And maybe that's the lesson hidden in every signal, real or false, that humanity is at its best when it dares to wonder, to collaborate, and to dream beyond its limits. Isn't that the kind of mindset that could transform not just our understanding of the stars, but our lives here on Earth? So let me leave you with this: the universe may be silent, but that doesn't mean we should be. Our search, our curiosity, our hunger to know, those are the voices that echo back at us. And one day, maybe, they'll meet another voice calling from across the stars. Until then, let's keep asking questions, keep pushing boundaries, and keep daring to imagine. And hey, don't forget to subscribe, hit the like button, and share this journey with someone who also wonders what's out there. Because the more of us who listen, the louder humanity's voice becomes.